हेलो माय डियर मैकेनिकल चैंपियंस, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? अपन किमेनाचेन येलवनारू. दिस इज चंद्रशेखर वेलकमिंग you all to the India's largest, the best and your favorite live learning platform, BYJU'S Exam Prep. Please do let me know if I am audible and visible to everyone so that we can start quickly. क्या मेरी आवाज आ रही है? आप लोग सुन पा रहे हैं मुझे? Those who are watching me live, please respond through the comment section. Hi Naveen, welcome, good evening. So as you can see, you are watching me through the part of the prediction series. Most expected type of questions, most predicted type of questions we bring in this series. Around 10 questions from each and every subject which we feel that those type of concepts are highly chances of getting repeated based on our experience, based on previous year papers. So today I will be having 10 questions from heat and mass transfer HMT for different areas of heat transfer, conduction, convection, radiation, heat exchanger, etc. So all the questions are having high potential of appearing in your actual GATE examination, which is going to be conducted on 4th of February. All right, Hemang, good evening. Welcome, guys. Welcome. Where are others? Please do share this session to all your friends so that others can also join and we can start. So this is my introduction for those who are here for the very first time. My name is Chandrashekhar, mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience, and based on my experience, based on my understanding about GATE examination, I have picked those special 10 questions which will be going to help you to improve your understanding of the concepts of different areas of heat transfer. All right. And I have also cleared engineering services examination. Teju, yes. Okay, Teju, definitely your point is noted. And I have also worked in Steel Authority of India Limited for a couple of years, and I am quite comfortable in these many subjects of mechanical engineering. If anybody is having any doubt in any type of doubt regarding your preparation, you can always come back to me, connect with me through the mail ID which is there on the screen, and I would highly recommend to join me on the Telegram, that is Mechanical by Chandrashekhar, and the link is also there on the screen. All right. Once you become part of my Telegram group, you will be getting these many benefits, and you can also have that discussion about your doubts, and you can also share your knowledge. All right, Ajay, welcome. Please keep your pen, notebook and calculator. We are about to start. Do not open the notes and the questions. Let me clearly tell you, the difficulty level of the question is on the higher side, little bit on the higher side. So do not get disappointed if you are not able to solve those questions. The objective of giving these type of difficult questions to prepare you for the worst situation. Otherwise, the GATE difficulty level will not be that tough. Right? One thing. And you should always think positive. Whenever you commit mistake, whenever you do not understand the question, learn from your mistakes. Try to improve those areas rather than getting demotivated by not getting the right answer, right? That promise yourself that till the final exam, you should never allow the negativity to enter into your mind. So other than the most predicted series, there is another series which is running on BYJU'S YouTube channel for civil and mechanical engineers, that is Formula Revision series. This is the complete schedule. You are already aware about that. So let us skip this portion. Prediction series, you are watching me through this prediction series only, and we are here at this level, heat transfer. Remaining topics will be covered in the next few days. All right, please give me thumbs up. Please show me some love please show some love to the subject, to the session, so that I also get motivated, I also get charged up to discuss these questions with you. Please write me in the comment section if you are all ready with your full enthusiasm, with your full positivity, full dedication. So without wasting much of your time, the last one more important point, or one more important information. You already are aware that after the GATE examination over, just after the GATE exam, we will be there to analyze the GATE examination. Complete detailed analysis will be there. And those who are appearing in GATE 2024 exam, there is a mega workshop for all the aspirants who are going to appear in the next year. Rakesh sir will be taking a special session. You should register for this workshop that is free of cost. He will be discussing 7 important points, golden rules to secure the best possible rank in GATE 2024. All right. So let us start with question number 1 on your screen. Question number 1 on your screen. Read the question carefully. Only 10 questions are there. So do not be in a hurry. Rather than you should understand each and every sentence of the question clearly. Do not commit silly mistakes. Do not be in hurry to commit the silly mistake, and try to observe the question completely and then do the calculation. All right. क्या बोल रहे तेजू? Within 30 minutes team GE questions. मेरे को समझ में नहीं आया. What is your point? So a hemispherical heat source, you can see over the screen, of radius 0.1 mm is embedded in a large medium. This is the medium. The medium is very large. Thermal conductivity of the medium is 1 to 5 watt per meter Kelvin and dissipates heat at the rate of 4 watt. Acha. Acha. How we will be able to get? We are having very high connection. Do not worry about that. There are students who are proactive in giving the questions to us. So we contact those students who are willing to give us the questions. So you do not have to worry about that. Even if we will not be able to get the correct data within 30 minutes, we will tell you whatever the situation will be. We will tell you everything. And for those questions which we are getting the data, we will discuss those questions. Everywhere we do like that. So that is not a problem for us. So it will start at 6, but it will continue till the last question. We will discuss each and every question in detail. So first of all, for initial 10-15 minutes, we will discuss the difficulty level, whatever the students provide us, the information we share with the students, and then gradually we get the questions. And the back end, there is a huge team working on the solution part. There is a huge team working on getting the questions. Everything will be pre-planned. So do not worry about that. Just focus on this question. Yes, 4 watt is the heat dissipation rate. All the boundaries of the medium are maintained at ambient temperature of 27 degrees Celsius, except for the plane surface that is insulated. This plane surface is insulated. Determine the surface temperature of the heat source. The question is to find out TS. The question is to find out TS. Can I expect the answer from any of you? Can I expect the answer for this question from any of you? So if we observe this heat source, there is a heat generated in the source, and whatever the heat generated in the source will be dissipated in radial direction in the medium. There will be heat dissipated in radial direction, and the mode of heat transfer will be conduction. Why conduction? Because the medium is given with the thermal conductivity. The rate of heat transfer in the medium is conduction. I hope this is clear. So according to, so we need to find out the surface temperature. So between the surface and the medium, the mode of heat transfer will be conduction. So according to the governing differential equation for conduction, if we apply the governing differential equation for conduction in spherical coordinate system, so we can say governing differential equation will be given by 1 by r square d by dr into r square into dt by dr is equal to 0. That is the governing differential equation, or we can write it as d by dr into r square into dt by dr is equal to 0. Isn't it? This is called as governing differential equation of conduction in spherical coordinate system. I hope you guys are aware about this expression. Now, if we integrate this equation two times, if we integrate this equation two times with respect to R, then we will get the temperature profile. So by integrating once, what we will get? If we integrate this equation, what do we get? Do we get R square into dt by dr is equal to C1? If we integrate once again, or we can write it as dt by dr is equal to C1 by R square. Then we need to integrate again. Can you do the integration? So we can say T is equal to integration of C1 by R square minus C1 by R plus C2. This is our expression. This is the temperature profile. And to find out the value of C1 and C2, we need two boundary conditions. And what are the boundary conditions? To find out the C1 and C2, we need two boundary conditions. At R is equal to R naught, temperature will be equal to Ts, which is unknown. At R is equal to infinite, it is the large medium. So the radius is infinite, R is infinite. So at R is infinite, T is equal to T infinity. Put the values to find out C1 and C2. Two boundary conditions, two unknowns. Can you do the calculation? If we put this value R is equal to R naught, R is equal to infinite, this will become 0, C2 will be equal to T infinity. So we will get C2 is equal to T infinity, and then from the first boundary condition, Ts is equal to minus C1 by R naught plus T infinity. So C1 will be equal to, what is C1? That is equal to R naught into T infinity minus Ts, isn't it? Is this correct? C1 and C2, R naught T infinity minus Ts. Put the value of C1 and C2 in the given expression. So if you put the value of C1 and C2 in the given expression, what do you get? If you put the value of C1 and C2, so T is equal to R naught by R, then it will be Ts minus T infinity plus T infinity. Is this the expression you will be getting? Is this the expression you will be getting? T is equal to R naught by R, Ts minus T infinity plus T infinity. And Q is given by, from the Fourier law, Q conduction can be written as, Q conduction will be equal to minus K into area. Area available for conduction is the area which is normal to the direction of conduction. That is 2 pi R square into dt by dr is equal to 4 watt. Isn't it? Can you find out dt by dr from here? So it will be minus K into 2 pi R square into, because it is a hemisphere, 2 pi R square into dt by dr. Let me put the value of dt by dr. If we put the value of dt by dr, then it will be R naught Ts minus T infinity, that is constant, and differentiate, that is minus 1 by R square, is equal to 4 watt. And this R square getting cancelled out, this R square getting cancelled out with this R square. So if we see, so 2 pi K into R naught into Ts minus T infinity is equal to 4. So Ts will be equal to, what will be the value? T infinity plus 4 upon 2 pi K R naught. Isn't it? Put the value, you will get the answer. Put the value, you will get the answer. What is the thermal conductivity? R naught is given as 0.1 mm and K is 125. R naught is given as 0.1 millimeter and K is equal to 125 watt per meter Kelvin. So put the value and you will get the answer. What is the answer? Sorry, let me write here. R naught is equal to 0.1 millimeter and the thermal conductivity of the medium is equal to 125 watt per meter Kelvin. Can you put the value and get me the answer? No, it is not correct, Hemang. Bataiye. Have you understood the question? Teju was asking for the derivation type of question. This is the derivation type of question. First question is derivation type. T infinity. What is the value of T infinity? T infinity is 27 degrees Celsius. T infinity is 27. I am still waiting for your answer. These are the parameters given which we require. What is the answer? Final answer. If you are able to write the expression correctly, then you will get the correct answer. Are you getting 77.9 or not? 77.93 degrees Celsius. Are you guys getting 77.93 degrees Celsius? Yes, Malesh, Shreyas, Manas, well done. This is the correct answer. Option C is the right answer. Have you understood the question or not? Bataiye. Is the question clear or not? I hope this is clear. Acha, Hemant. Acha, 350.9K. Acha, all right. I hope this is clear. If anybody is having anything to ask, you can just let me know. Now let us move to the next question. Common data question for 2 and 3. Common data question for 2nd and 3rd. This is simple, but a little bit of lengthy. Sometimes more calculative questions you should also practice to improve your calculation part. This is calculative, but not tough. A tube of steel has an inner diameter of 36 mm. It is a steel tube. It means a cylinder. The question is from cylindrical system. Inner diameter of 36 mm. So we can say R1 is equal to 18 mm. And the wall thickness of 2 mm. It means R2 will be equal to 18 plus 2, 20 mm. Isn't it? Isn't it? The thickness of the wall is 2 mm. So it means outer radius will be 20 mm. The is used to carry the chilled water. The chilled water and the ambient air are at temperature of 6 degree. This is 6 degrees Celsius and the ambient air is having a temperature of 23 degrees Celsius. And corresponding inner and outer convective heat transfer coefficients are 400. This is having HI is equal to 400 watt per meter square Kelvin and H naught is equal to 6 watt per meter square Kelvin. If the thermal conductivity of the steel is given as 14.4, then what is the heat gained by the chilled water per unit length of the tube? What is the heat gain? So the question is from the composite system involving combined modes of heat transfer. It is a single system. It is combined modes of heat transfer for a cylindrical system. So that will be analyzed by using circuit diagram. How many thermal resistances will be there? If we analyze it by using circuit diagram, how many thermal resistances will be there? There will be 3 thermal resistances, isn't it? Between 23 H0 and T0 and Ti. The direction of heat flow from the is towards radial inward. The direction of heat flow is radial inward. Q. There will be 3 thermal resistances. So if we want to write Q, then we can say 2 pi L into T naught minus T upon, can we write it as 1 upon Hi into R1 plus ln of R2 by R1 upon K plus 1 upon H naught into R2. That will be the expression. Put the value, we need to find out. Length is taken as 1 meter. So it will be 23 minus 6, that is 17 into 2. 17 into 2. 34 pi, isn't it? Isn't it? 34 pi numerator. 34 pi divided by 1 upon HI. What is the value of HI? 400 into R1. R1 is 18 mm. So 0.018, isn't it? Plus ln of R2 by R1 upon thermal conductivity. Thermal conductivity will be 14.4 plus 1 upon H naught, that is 6 into 20 mm. So 0.02. That will be the denominator. Can you find out the value of Q by L? Can you find out the value of Q by L? Are you guys getting? Yes, 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 yes. Very nice. Hemang, Shreyas, Manas. Are you getting 12.59 something? 12.6 watt per meter. Are you getting 12.6? Question is simple, but you should be clear with the circuit diagram, the number of resistances, and more importantly, you should be able to do the calculation fast and accurate. You should be able to do the calculation fast and accurate. That is important in this question. So the answer to this question is B. So let us proceed to the third question, which is the sharing the same data as that of the previous question. What is the heat gain per unit length when 10 mm thick layer of insulation is applied to the tube? It means now it becomes the composite system. If 10 mm thick layer of insulation is provided, R1 was 18 mm, R2 is equal to 20 mm, and what is R3? R3 will become 30 mm, and the insulating material is having a thermal conductivity this. So R equivalent, if we want to write now 1 upon, or it will be 2 pi L if we take common because it is a, then 1 upon HI into R1 plus, or let me write here, R equivalent if we write, then 1 upon 2 pi L, then 1 upon HI into R1 plus ln of R2 by R1 upon K1 plus ln of R3 by R2 upon K insulation plus 1 upon H naught into R3. That will be the expression, and Q is equal to delta T overall upon R equivalent. Can you do the calculation? Oh my God, seriously, Shreyas? Are you getting the answer so fast? So again, it will be 2 pi L into 23 minus 6 is the numerator, and the denominator can be written as 1 upon HI is equal to 400 into 0.018. It will remain same. Ln of 20 by 18 upon 14.4, that will also remain same. Ln of R3, that is 30 by 20 upon K insulation, that is 0.05. Plus 1 upon H naught is 6, and R3 has become 30 mm now. So it will be 0.03. This will give you the answer. So we can easily find out Q by L for this. Can you find out Q by L for this? Yes. Are you guys getting around 7.7? Are you guys getting around 7.7? Please do let me know. If we are getting the value 7.7 watt per meter. Please do the calculation fast and let me know the answer. Everyone, those who are watching me live, I want you guys to solve this. And if anybody is having any doubt, you can just let me know. So this is all about question 2 and 3. You should be able to write R1, R2, R3 correctly based on the thickness given. Thickness, if thickness is given, then R2 will be equal to R1 plus thickness, and R3 will be equal to R2 plus thickness. Are you able to hear me or see me? Am I audible and visible to everyone? Can we proceed further? when I see, when I hear, I forget. Whenever you hear something, you might forget. But whenever you see something, you remember. And when you do, then only you understand. So by knowing the things will not help you. You need to understand the concept, and that comes only with the practice. So that is why this session is planned for the last moment practice. And there is a mock test which is running, All India Open Mega Mock Test for GATE 2023 aspirants from 24th to 30th of January. Are you guys able to hear me or see me? Please respond through the comment section. अच्छा, बोल रहे हैं आप, and I am not able to see your comments actually. I am not able to see your comments. Okay, so that is. चलिए, let us proceed further. And for the scholarship, you can register using the mentioned link in the description box. So let us move to the next question. Let us solve the next one then. Question 4 and 5. Question number 4 and 5 are again the common data question. The questions are from the convection. Consider parallel flow involving stationary and moving plates. Yeah. Yes, now I will be able to see. Right. So read the question and try to solve it. Consider parallel flow involving stationary and moving plate. The bottom plate is stationary and the top plate is moving. Of infinite extent, separated by a distance L is equal to 3 mm. They are separated by 3 mm. With the intervening space filled by an incompressible fluid. There is an incompressible fluid in between. The speed of the moving fluid is 10 meter per second, that is capital U, and the temperature of the stationary and moving plate are mentioned as 10 degrees Celsius and 30 degrees Celsius respectively. The temperature distribution is given by in the fluid. The temperature distribution in the fluid. This is Y is equal to 0. This is Y is equal to L. And temperature is a function of Y. In the fluid, the temperature varies with Y, and the temperature variation with Y is given by this expression. All right, where Y is the distance from the stationary plate, viscosity of the fluid, dynamic viscosity of the fluid is given by this value, and the thermal conductivity is given by 0.4145. All right, this is the data, and the question is on the next screen. What should be the location of maximum temperature of the liquid? Can you find out the location of maximum temperature for the fluid? So for temperature to be maximum, what we can say, differentiation of temperature with respect to Y must be 0, isn't it? For temperature to be maximum, differentiation must be 0. So if we want to find out the value of Y where the temperature is maximum, then take the differentiation with respect to Y and put it as 0. Do the differentiation and put it as 0. So from here we can say dt by dy is given by mu into u square by 2k. Then it will be 1 by L minus 1 by L square. Y square, differentiation of Y square is 2y L square plus TL minus T naught into 1 by L, isn't it? If we put it as 0, then what? Then we can say 1 by L minus 2y by L square is equal to minus 2k upon mu u square into TL minus T naught into 1 by L. isn't it? And we can say 2y by L square is equal to, what is 2y by L square? That is equal to 1 by L, then it will become plus 2k by mu u square into 1 by L into TL minus T naught. So if we cancel this L here, then y will be equal to, then it will become L by 2, then 1 plus 2k upon mu u square into TL minus T naught. Can you find out the value of y? Can you find out the value of y? Thermal conductivity is given as, we require thermal conductivity 0.145. The thermal conductivity is given as 0.145. Thermal conductivity K is equal to 0.145. Viscosity is given as, what is the viscosity given? Viscosity is given as 0.799. 0.799 Pascal second. It is already in there. It is SI unit. 0.799 and U is equal to 10 meter per second. TL is equal to, TL will be equal to 30 and T naught is equal to 10, isn't it? TL is equal to 30 and T naught is equal to 10. Put these values, get me the answer for y. What is the value of y? The value of y will be, very well done. There are intelligent students in the session. 1.61 mm. Are you getting 1.61 mm? 1.608 something? Are you guys getting 1.608 millimeter? So it is around 1.61. D is the right answer. Very well. Very well done. Good, good, good. Good guys, keep it up. Sarath, Shreyas, Semang, well done. Those who have not the correct answer, please do try. For temperature to be maximum, what we need to do is the differentiation of temperature with respect to y must be 0. So corresponding y we can calculate. And the next part of the question is, what is the value of the maximum temperature? That you can solve. Then you can solve it. What is the value of maximum temperature? At y is equal to 1.61 millimeter, we can find out the temperature to be maximum. So put the value of, in this temperature profile, this T will become T maximum if y will become 1.61 millimeter. Can you find out the value of T maximum now? Thermal conductivity is 0.145, mu is equal to 0.799, T L is equal to 30 degrees Celsius, T naught is equal to 10 degrees Celsius. What else? U is equal to 10 meter per second. These are the parameters. Anything else we require? No. And y we are supposed to put as 1.61 mm. So what is the maximum temperature? Can you find it out? Put the value of y as 1.61 mm. Put the value of y in its SI unit. Y by L. Okay. Even if you put it in millimeter, then it will not be a problem. So y by L, that is equal to 1.61 by 3. Y by L is 1.61 by 3. That will be equal to, what is y by L? You can find it out, y by L, because there is y by L in each and every term. Here also, here also. So what is the answer? I want you guys to get me the value of T maximum. Is it 89.24? Are you guys getting 89.24? If you will not commit any mistake, then you will get the value 89.24. Is it 79.24 or 89.24? We need to add this T naught also. We need to add this T naught also. T naught is 10. 89.24. Yes, Ajay. This value will give 79.24, but T naught will also be added. So 89.24 is the correct answer. C is the right answer. Yes. So we are halfway, 5 more questions to go. I hope you guys are enjoying. Please like this session so that others can also practice these questions if they are not able to come live. And again, you must be aware that there are 3 consecutive marathon sessions are running. Today it was engineering mathematics, and tomorrow don't forget to join at 10 a.m. for general ability taken by BYJU'S Sir. So please do join the YouTube channel, BYJU'S YouTube channel for civil and mechanical engineers, so that you get the understanding, or you get the concept clear for aptitude before your final exam. All right. So shall we move to the next question? Ready for the next one? Please give me thumbs up if you are ready for question number 6. Question number 6 on the screen. चलता रहूंगा पथ पर, चलने में माहिर बन जाऊंगा. चलता रहूंगा पथ पर तो चलने में माहिर बन जाऊंगा. या तो मंजिल मिल जाएगी या फिर अच्छा मुसाफिर बन जाऊंगा. So you should continue your preparation without bothering for the result. If your preparation is on track, then definitely you will get the success. Success can be delayed but cannot be denied if you are doing your preparation in the right direction. Right direction is very, very important, and your full dedication, hard work, enthusiasm is very, very important. Let us move to the question number 6. Again from the convection. Oil which is at 25 degrees Celsius flowing at, this is T infinity, flows at a velocity of 0.1 meter per second over a flat plate in a certain process. The plate is 4.5 meter long. The length of the plate is 4.5 meter and is maintained at a uniform temperature of 95 degrees Celsius. Surface temperature is 95. The thermophysical properties of oil at the mean flow temperature, that is the film temperature, 95 plus 25 by 2, 60 degrees Celsius. Density of the oil is given. Thermal diffusivity is given. Thermal conductivity is given. And the kinematic viscosity is given. These are the parameters given. Now, your turn. What will be the thermal boundary layer thickness at the trailing edge of the plate? Delta T at X is equal to L will be how much? You need to find out the thermal boundary layer. Can you solve it? What should be the first step? The question is from boundary layer theory or external flow. The question is from the external flow. What will be the first step to check whether the flow is laminar or turbulent? Because there are different formula for laminar boundary layer. There are different formula for turbulent boundary layer. So you need to check. No manners. First of all, you need to check whether it is laminar or turbulent, because it is not mentioned. So you need to check the maximum value of Reynolds number that is equal to the trailing edge. So we can write U infinity into L by kinematic viscosity. What is the value of Reynolds number, maximum Reynolds number, which can be possible? Or the Reynolds number at the trailing edge. We need to find out the Reynolds number at the trailing edge, because the question is about to find out the value of thermal boundary layer thickness at X is equal to L. U infinity, the velocity of the fluid is 0.1 into 4.5 upon kinematic viscosity 0.65 into 10 to the power minus 4. That will give you the value of Reynolds number. So the Reynolds number is equal to, what is the value of Reynolds number? 6923.07, because it is less than 5 into 10 to the power 5. So what type of boundary layer is? It is laminar boundary layer. I hope this is clear to you, because the boundary layer is laminar. Very nice. And once you understand that the boundary layer is laminar, then we should use the formula for laminar boundary layer. And for laminar boundary layer, the hydrodynamic boundary layer thickness is given by 5x upon under root of Rex. So delta at x is equal to L is equal to 5 into L upon under root of Rel. First of all, we need to find out the hydrodynamic or velocity boundary layer thickness. Isn't it? 5 into 1.45. 4.5. It is not 1.45. 5 into 4.5. Divide by under root of Reynolds number. The value of Reynolds number we have already calculated, 6923.07. So first of all, you need to find out delta L. What is that? How much is the value of velocity boundary layer thickness? Okay, Shreyas had given the final answer. So delta L is equal to, delta L will be equal to 0.27 or 20.04 mm or 270.4 mm, isn't it? 270.4 millimeter. Are you getting it? 270.4 millimeter. And for laminar boundary layer, delta x by delta t is equal to Prandtl number to the power 1 by 3, where Prandtl number is equal to kinematic viscosity upon thermal diffusivity. Kinematic viscosity is given as 0.65 into 10 to the power minus 4. 0.65 into 10 to the power minus 4. And the thermal diffusivity is given as 7.2 into 10 to the power minus 8. 7.2 into 10 to the power minus 8. So the Prandtl number is equal to 902.77. 902.77, that is the value of Prandtl number. So find out delta T, which is equal to delta L by Prandtl number to the power 1 by 3. Put the value 270.4 millimeter. Prandtl number is 902.77 to the power 1 by 3 will give you the answer, isn't it? So if you will do the calculation correctly, the thermal boundary layer thickness at the trailing edge will be equal to 27.98 millimeter. Are you guys getting the answer or not? Is this clear? If the flow would have been turbulent, if it would have been the turbulent boundary layer, if it would have been turbulent boundary layer, if it would have been turbulent boundary layer, then what would have been the expression? Then delta x would have been equal to delta t, that is 0.376 x upon Re to the power 1 by 5. Do you remember? If Reynolds number would have been more than 5 into 10 to the power 5, if the Reynolds number would have been more than 5 into 10 to the power 5, then delta x and delta t would have been equal. But there would not have been any connection with the Prandtl number. For turbulent boundary layer, Prandtl number is insignificant. But for laminar boundary layer, it is the Prandtl number which decide whether the thermal boundary layer thickness will be more or the velocity boundary layer thickness will be more. I hope this is clear to everyone. This question, did I give you this question to my Telegram group? Did you try this one? This was the question which was given for challenge yesterday. How many of you are aware about that? Please drop me a yes in the comment section. How many of you know about this question? If you are part of my Telegram group or if you are part of any WhatsApp group for the students, I had shared this question everywhere yesterday and I had got the right answer from someone. I had also get the right answer. Anyone here who gave me the right answer yesterday? Can you try this one? Beautiful question from the radiation shape factor. We need to find out F223. The question is about F223. Anybody here can give me the right answer? The shape factors are given. These are the given shape factor and the area we can easily calculate. The dimensions are given. So can we say, if you are interested in F223, can we say A2 into F223 is equal to A3 into F322 from the reciprocity theorem? From the reciprocity theorem, can we say A2 into F223 is equal to A3 into F322? So F2 to 3 is actually A3 by A2 into F3 to 2. A3 we can easily find out 4 by 8. This is surface 3. A2 we can easily find out, that is 2 by 8. Right? This complete is surface 6 and this complete is surface 5. So 2 plus 4 is 6. We can say A6 is equal to A2 plus A4 and here A5 is equal to A1 plus A3. That is also given. So 5 is the surface which is 3 plus 1 and 6 is the surface which is 2 plus 4. Now our objective is to find out F3 to 2 because we do not know F3 to 2. Anybody who is able to solve the answer, solve the question, please do share your answer. Do share your answer. F3 to 2. 3 to 2. Can we say Q 5 to 6? Can we write Can we say Q? We are interested in 3 to 2. Can we say Q 5 to 2 is equal to Q 5 to, or it can be written as Q 3 to 2 plus Q 1 to 2. That is the energy equation. Please do let me know. This is the catch. Can we say Q 5 to 2? 5 is the total surface. The radiation leaving from 5 and reaching to 2 can be written as the radiation leaving from 3 to 2 plus the radiation from 1 to 2. Is this clear? This expression. Can we write this? And Q5 to 2 can be written as A5 into F5 to 2 is equal to Q3 to 2 can be written as Q3 to 2 A3 into F3 to 2 plus Q1 to 2 can be written as A1 into F1 to 2, isn't it? So if we are interested in A3 F3 to 2, we are interested in A3 F3 to 2, so we can write A3 F3 to 2 as A5 into F5 to 2 minus A1 F1 to 2. Please do let me know if you are able to understand this step. A3 F3 to 2 is equal to A5 F5 to 2 minus A1 F1 to 2. Is this clear up to this point? What did we write? A3 F3 to 2 is equal to A5 F5 to 2 minus A1 F1 to 2. Now, if we can find out these two values, how? If we can find out these two values, F5 to 2. So we can say F5 to 2 can be written as can we write Q 5 to 6 is equal to, this is 5, this is 6, is equal to Q 5 to 2 plus Q 5 to 4, or that can be written as A5 F5 to 6 is equal to A5 F5 to 2 plus A5 F5 to 4. Here A5 will get cancelled out. So F5 to 2, F5 to 2 can be written as F5 to 6 minus F5 to 4. Why we are calculating this? Because F5 to 6 and F5 to 4 are given. So F5 to 2 will be this. And similarly, because 1 to 6 and 1 to 4 are given, 1 to 6 and 1 to 4 are given. So can we write F1 to F5 to 2? Can we write F5 to 2? Or similarly, can we write F1 to 6 or Q1 to 6? is equal to Q126 is equal to Q122 plus Q124, isn't it? Q126 is equal to Q122 plus Q124, or we can write A1 F126 is equal to A1 F122 plus A1 into F124, A1 getting cancelled out. So from here we can write F122 is equal to F126 minus F124. If we put these values in this expression, so our this expression will become A3 F322 is equal to A5. Then F522 is, we can write F526 minus F524 minus A1 multiplied by F122. We can write F122. F122 is F126 minus F124. If anybody is having any doubt, you can just let me know. So put the value of A5. What is A5? That is 4 plus 3, 7 into 8. 7 into 8. F526 minus F524. 0.3 minus 0.2. This is 0.3 minus 0.2. That is 0.1. Minus A1. What is A1? 3 into 8. F126 minus F124. That is equal to 0.4 minus 0.3. Isn't it? So it will be 5.6 minus 2.4. That is equal to 3.2. A3 F322 is equal to 3.2. And we are interested in F122, that is A3. Sorry, what was that? We are interested in F223. We are interested in F223 is equal to F322 upon A2. Sorry. That will give you the answer. So numerator is 3.2, denominator is A2. What is A2? 2 by 8. It is 2 into 8. So F223 finally is 0.2. This is the final answer. This will be the answer. Yes, look, 5 is this surface, 6 is this surface. Let me call 5 to be radiating surface and 6 is the receiving surface. 6 is the receiving surface. So the radiation leaving from 5 and reaching 6 is equal to the sum of radiation leaving 5 and reaching 2 plus the radiation leaving, or how, what are you talking about? 5 to 6. Are you talking about 5 to 6? The first expression, right? 5 to 6. Q5 to 6 you are talking about. Q5 to 6. Yes. Q5 to 6 is equal to Q5 to 2 plus Q5 to 4. Isn't it? Are you talking about this, Ajay? And Q1 to 2 is proportional to A1 F1 to 2. That you should know. Q1 to 2 is proportional to A1 into F1 to 2. So Q5 to 6, it is energy equation. Na? The total radiation leaving 5 and reaching 6 is sum of the radiation leaving 5 and reaching 2 plus radiation leaving 5 and reaching 4. Because 6 is divided into 2 parts. Isn't it? The most important is actually, the most important expression is actually this one. Q5 to 2. This, because here the area will not be same. Q5 to 2 can be written as 3 to 2 plus 1 to 2. 3 to 2 plus 1 to 2. So here area, for this area will be taken as A3, here area will be taken as A1 and here area will be taken as A5. That is important. We cannot write, if Q5 to 2 is equal to Q3 to 2 plus Q1 to 2, we cannot write F5 to 2 is equal to F3 to 2 plus F1 to 2. That is not correct. We cannot write F5 to 2 is equal to F3 to 2 plus F1 to 2. No, there are areas which are involved here. I hope this is clear. And once your GATE exam will be over, then we will focus on the ESE prelims, and for that non-technical marathon session will be started on YouTube, BYJU'S YouTube channel for civil and mechanical engineers from 13th of February. So do not forget to join these marathon sessions also. Right. So let us move to question number 8. Question number 8. This is simple now. This question will be simple. Question number 8. Find the heat exchange between 1 and 2 for the given configuration. This is surface 1, this is surface 2. So we need to find out F1, Q1 to 2. So if we calculate Q1 to 2 is equal to sigma into A1 into T1 to the power 4 minus T2 to the power 4 divide by both are non-black surfaces. So 1 minus epsilon 1 upon epsilon 1 plus 1 upon F1 to 2 plus A1 by A2 multiplied by 1 minus epsilon 2 upon epsilon 2. That is the expression. I hope you guys know about this expression. That is the expression using the circuit diagram. Now sigma known to us, A1 is also known to us 5 by 4. T1 temperatures must be in Kelvin, they are in degrees Celsius. Epsilon 1, epsilon 2, everything is given. Now we must find the value of F1 to 2. We need to find out F1 to 2. Can you find out F1 to 2? So our actual objective is to find out the value of F1 to 2. If we are able to find this out correctly, now your turn. I want you guys to find out the value of F1 to 2. Get me the value of F1 to 2. Once you will be able to get the value of F1 to 1 to 2 correctly, then you will get the answer correct. Please, everyone, give it a try. The analysis will be simple, similar to the previous question. Now, Sharath, I don't think yours is correct. Check F1 to 2, na? Question number 8. F1 to 2. Yes, please check. I don't think your answer is correct for F1 to 2. I am waiting for everyone to get me the answer for F1 to 2 correctly. F1 to 2. Can you find out the value of F1 to 2? अगर भरोसा खुद पे करो तो ताकत बन जाती है और अगर दूसरों पे करो तो कमजोरी. So you should trust yourself. You should trust your preparation. Don't overthink. Otherwise, negativity, demotivation, disappointment will start coming to your mind. That is dangerous. So keep yourself positive. Whatever your preparation is, try to encase that preparation into marks. Whatever you have studied, if you are able to apply those concepts in your examination, that your examination will be good. F1 to 2. Question is how to find out F1 to 2. We can write A1 F1 to 2 is equal to A2 F2 to 1, isn't it? Why? Because 2 to 4, 2 to 3, these are the given values of shape factors. So F1 to 2 is equal to, if we can find out A2 F2 to 1. Yes. Can we write, this is 2. Can we write Q2 to 4? 4 is the surface combination of 1 and 3. A4 is equal to A1 plus A3. Can we write Q2 to 4 is equal to Q2 to 1 plus Q2 to 3? Energy equation, energy conservation equation. Can we write Q2 to 4 is equal to Q2 to 1 plus Q2 to 3? And that can be written as A2 F2 to 4 is equal to A2 F2 to 1 plus A2 F2 to 3. Area getting cancelled out everywhere. So F2 to 1 is equal to F2 to 4 minus F2 to 3. What is F2 to 4? 0.35, F2 to 3, 0.29. So it will be 0.35 minus 0.29. That is F2 to 1. Isn't it? So F2 to 1 is equal to, how much is that? 0.06. It is F2 to 1. Sarath, we were interested in F1 to 2. So what we can write is F1 to 2 is equal to A2 F2 to 1 upon A1. What is A2? A2 1.5 into 5 into F2 to 1 0.06. What is A1? 5 into 4. 5 getting cancelled out. So F1 to 2 will be equal to 0.0225. Yes, that will be the answer, and put in equation number 1. If we put in equation number 1, this is equation number 1, then you will get the answer. So if we put the values in equation number 1, then Q1 to 2 is equal to sigma 5.67 into 10 to the power minus 8. Area A1, that is 5 into 4 into T1 to the power 4. T1 is actually in degrees Celsius, 400 and 200. So add 273. 673 to the power 4. 473 to the power 4. That is the numerator. Isn't it? Then 1 minus epsilon 1. Epsilon 1 was 0.8. Epsilon 2 was 0.9. Epsilon 1 0.8, epsilon 2 0.9. So 1 minus 0.8, that is 0.2 by 0.8 plus 1 upon F1 to 0.025 plus A1 by A2. A1 is 5 into 4 by A2. A2 is 5 into 1.5 into 1 minus epsilon 2. Epsilon 2, that is 0.1 upon 0.9. That will give you the answer in watt or joule per second. Your answer is coming in joule per second, isn't it? Your answer will be in joule per second. Can you solve it? 5 getting cancelled out. So Q1 to 2 in joule per second, how much is that? If you want to convert it into kilocalorie per hour, the question is about, the options are in kilocalorie per hour. So 1 calorie is equal to 4.18 joule, isn't it? 1 calorie is equal to 4.18, or 1 joule is equal to 1 joule is equal to 1 divided by 4.18 calorie. So what is the answer? What is the final answer? Is it 3909.08 in watt? Are you getting it? 3909. Are you getting around this? Joule per second? 3909? Yes, joule per second. So convert it into joule, will be converted 3909 divided by 4.18, isn't it? To convert it into calorie, and second will be converted into hour. This will give you the answer. What is the answer? What is the final answer? It is around. Please check. Are you getting 3366 something? 3366 something? So it is 3366. The nearest option will be treated correct. Whatever is the nearest option will be treated correct. So 3366. It means almost 3400. A is the correct answer for this one. Option A. A will be the right answer. Yes, very nice. Shreyas, Manas, Hemang, well done guys, well done. Ajay, good. Option A. Let us move to question number 9. From the heat exchanger, there are 2 more questions. I will take 5 more minutes to discuss these 2 questions, and please try to solve these questions again independently. That will improve your understanding. That will improve your concept. So there is a shell and tube type of heat exchanger is designed to heat 2.5 kilogram per second of water. Water is the cold fluid from 15 to 85 degrees Celsius. The heating is to be accomplished by passing hot engine oil, that is the hot fluid. Oil is the hot fluid, which is available at 160 degrees Celsius through a shell side of the heat exchanger. Oil is through the shell side and leaves the exchanger at 100 degrees Celsius. All right. The temperatures of hot fluid are 160 and 100, cold fluid 15 and 85. The overall heat transfer coefficient is 354 watt per meter square Kelvin. 10 tubes passes of water is used. It is a shell and tube type. So shell and tube type, what type of flow it is? Do you agree it is cross flow heat exchanger? In shell and tube type, the flow is cross. Each tube is thin walled of diameter 25 mm. If the correction factor for the LMTD is 0.87, how long must be the tubes to accomplish the desired heating? It means the length of the tubes must be what? We need to find out the length of the tube. How long will be the tube to accomplish the desired heating? So if we find out LMTD, so LMTD is F into LMTD for counterflow heat exchanger. The correction factor multiplied by LMTD for counter, isn't it? So if we can find out LMTD for counterflow heat exchanger, oil is the hot fluid that is at 160 degrees Celsius and 100 degrees Celsius, and the cold fluid is water. Cold fluid is water. Then it is moving from 15 degrees Celsius to 85 degrees Celsius. First of all, find out LMTD. So delta Tm for this heat exchanger is 0.87 multiplied by 160 minus 85 minus 100 minus 15 divided by natural log of 160 minus 85 upon 100 minus 15. That will give you the value of LMTD. First of all, find out the value of LMTD. Can you get me the LMTD for this heat exchanger? What is the value of LMTD for this shell and tube type or cross flow heat exchanger? What is LMTD? Are you getting 79? Is it 79 or is it 69.5? Do not forget to multiply with 0.87. If we multiply with 0.87, it will be 69.5. Isn't it 69.5? Malesh, you forgot to multiply with 0.87 because it is not counterflow. It is actually the cross flow heat exchanger. Now we can write Q is equal to Cc into delta Tc is equal to U into A into delta Tm. So mass flow rate into specific heat. What is the mass flow rate of the cold fluid? Water is the cold fluid and water is having a mass flow rate 2.5 kg per second and the specific heat of water is given as 4.18. So 2.5 multiplied by 4180, temperature difference for the cold fluid 85 minus 15 is equal to overall heat transfer coefficient, that is 354. What is area? We can say number of passes into pi into d into L into delta Tm, that is 69.5. N is equal to 10. The value of N will be equal to 10. So put the value 2.5 into 4180 into 65. Is it 60? Sorry. Or 70. So it will be 70 is equal to 354 is equal to 354 into 10 into pi into diameter. What is the diameter? Diameter is 25 mm. So 0.025 into L is unknown into 69.5. So what is the length? We can find out. The only unknown is L. The only unknown is L. What is the value of L? Are you getting 37.85 meter? What is the value of L? Is it 37.85 meter or not? A is the answer. Please do check. The length of the tubes will be 37.85. And the last question is your assignment. This is your assignment question. Question number 10 is your assignment question. Please do solve this question and share your answer to my Telegram group. Do solve this one and share me the answer. It is again from the heat exchanger. You can take the screenshot and I will share the PDF also for this session. Do solve this question at home and bring me the solution. All right. And if you have any doubt, you can just let me know through the Telegram group. I will be more than happy to discuss your confusion. So that is all from my side for this. So if you are not part of my Telegram group yet, please do join me. That is Mechanical by Chandrashekhar. I hope you have liked the session. You have enjoyed it. If you have not liked the session, if you have not clicked the like button, please do that and share, and do not forget to subscribe the BYJU'S YouTube channel. All right. So that is all from my side. See you in the next session and all the very best and enjoy. Take care. Have a good day and a great future ahead. Thank you. Jai Hind.